logical reason why you did what you did, usually there's some grace there. Caleb, 3. Number 3, 2/3 of 119. Okay? Now we can look at this a couple of different ways. First way is maybe what you did is you rounded this because it was a regular fraction to 0, half, or 1. Maybe you went what? Maybe you went 1. If you went 1, there's no reason why you would need to change the 119. You could just keep it at 119 because estimating or doing this work in your head, 1 times 119 isn't that bad. Did you have 120? Did anyone have 120? You had 120. Next time, though, if it's just times 1, I mean, if it was 120 on the test, depending on my mood, I might let it go. But there's really no reason why you'd have to round the 119 if you're just multiplying by 1. Okay? Because if this was 87 and 87.4, you multiply it by 1, it's still 87.4. Now, the other side of it is this. 2/3 of 119. Okay? If we look at the 119 and we look at the 3, and we say, okay, I'm going to look at these first 2 digits in the 119. What number closest to 11 is divisible by 3? 12. So I would make that a 120. What is 12 divided by 3? 4 with the 0 makes it, how many 40s are we talking about? Which would give you 80. Okay? Either way, I would accept either one of those, okay, depending on the method you chose. Alex? Are we good with 3? 2. 4 and 2/5, 5 and 5/9. Both mixed numbers, both rounded to the nearest whole. Looking at the fractions, half is going to determine whether this whole number stays at a 4 or if it goes up to 5. Is 2/5 less than, equal to, or greater than half? It is less than, therefore this is a 4. 5/9, less than, equal to, or greater than half? What's half of 9? 4 and 4.5. So is 5 bigger than 4.5? So that's bigger than half. That's why it goes to a 6. And go 10. Okay. Do you see why this is greater than half? Because if it were exactly half, it would be 4.5. Since it's a 5 and not a 4.5, 5 is bigger than half. Okay. If you're still not sure, are there any other options you could do with the 5/9 to find out for sure? Could you put it in a decimal? What is half as a decimal? 0.5. If I were to just run this 5/9 through a decimal test, say, okay, there's a 5, 0.55 greater than 0.5? No? Because 0.5, what comes next? If it's just 0.5, what comes next? A 0. You have a 5 here, so it would be bigger. Okay? Chris? No. Because we have very specific rules. When we work with mixed numbers, you round to the nearest whole. So if you say 4.5 and 5.5, you're not rounding to the nearest whole because you still have a fraction. Okay? So that's why it would not be acceptable. Anything else on 1 through 6? Yes? 4. 2 and 7/8 times 4 2/3. So again, rounding to the nearest whole, as I look at 7/8, is that, well, how is that in relation to half? Is that less than half or greater than half? Greater. So if it's greater than half, what happens to the 2? It goes up to a 3. Times 2/3. What's 2/3 relationship to half? It's greater. What's half of 3, right? 1 1/2. So greater means I round up. 3 times 5 becomes... You probably did 4. 3 times 4. Probably didn't round up that 2/3 to, to 5, to be more than half. Yes. Anything else in that section? How about 7 through 12? Oh, Chris, anything more in that section? Number 6. 23 and 9/10 divided by 12 and 1/4. It's a good question because when I would always recommend, if there's division that's happening and even if you're estimating, always look at that one first. Okay? And I'll explain why in a minute. 12 and 1/4, if we take it straight up, rounds to what? 12. Okay? Now, I'm going to round this one straight up and see if it works. 23 and 9/10 would go to what? 24 divided by 12 is 2. It works. Okay? You look at this one first because even if you round this one straight up, say, just for example, that it was 23 and 3/10. And you rounded it straight up, and you had this divided by 12, and you ended up with a 23. Knowing that you're estimating, what would you say about this 23? You'd say, you know what? It's awfully close to 24. I'm going to use that compatible number. I'm going to divide. I'm estimating anyway. I'd say it's 2. Okay? That's why you look at what you're dividing by first. Okay? 7 through 12. Alex. Number 9. 2 and 1/3, 4 and 3/5. Common denominator between a 3 and a 5 is 15. 3 times 5 gives us 15. 1 times 5. 5 times 3. 3 times 3. So 5 plus 9. And 2 plus 4 is 6. Yeah, you gotta make sure you add the mixed number. Add the whole number in that mixed number. Anything else in that section? Chris? Good. 7/8 minus 3/5. Common denominator? 8 times 5. 7 times 5. Times 8. Times 8. 35 minus 24. Africa? 7. 2/3 minus 5/12. Common denominator, let's use the 12. That'll stay at a 5. 3 times 4 is 12. 4 times 2 is 8. 8 minus 5. 3 over 12 becomes both divisible by 3. Got to simplify. Anything on 13? 13? Yeah. So we're going to add. It was at 21 and 3/8. And we're going to add 4.5. Let's keep it at 8 and 4/8, 7/8, and 25. Yes. Uh-huh. Yes? 14. Are we done with 7 through 13? Yes? Three-eighths times 4/9, number 14. Multiplication, fraction form, we're good. We're just going to look diagonally to see if there's anything that we can reduce. 3 and 9 I can reduce both by dividing by 3. And 8 and 4 by dividing by 1 times 1, 2 times 3. You flipped when you shouldn't have flipped. You flipped. You flipped. You made the 4/9 a 9/4. That's multiplication, not division. Sophia, you only flip on division. Only flip on division. Watch. There's some logic here. Watch. There's some logic here. If we take a look at number 14 straight up, before I'm not even touching this part. If I wanted to, could I go ahead and just multiply? Could I do that? Obviously, I just did. Now, the problem is this, okay? I don't have to flip for multiplication because I can take any two numbers and multiply them. Multiplication, any two numbers are compatible. But I'll take this same problem, but I'll put a division sign in between. Okay? Can I just divide going across? 3 divided by 4, does that work? 8 divided by 9? That doesn't work. See, division doesn't work the same way as multiplication does. I can't just divide any two numbers that I want to, just because they're there. All right? So that's why we have to flip. And then if we flip, then I switch it to multiplication, and then I'm back to multiplying any two numbers I want. Remember, we've shown this? I've shown this to you this way. If you were using division, how would you cut something in half? You would divide by 2. So let's take, for example, 8 divided by 2. You all know ahead of time the answer is going to be 4. But if I'm going to set it up in a fraction form, and I said this, okay, funny way it still kind of works out this way, but if I say, all right, you know what, it's division, I'm going to flip. Dividing by 2 is the same as multiplying by half, by its reciprocal. Because 8 over 2 is going to give me the 4 I'm looking for. So even if you go back here, dividing by 4/9, the same thing as multiplying by 9/4 when you flip it. Okay? So you only flip when you divide. Sophia, 16. 2 and 3/8, 4 and 4/5. All right? Need them in fraction form. 16 plus 3, 19 over 8. 20 plus 4, 24 over 5. Any question on how to get to an improper fraction? No? Good? Diagonally, 19 and 5, can I reduce them at all? How about 24 and 8? Dividing them both by what? 19 times 3, 57. 57 over 5. Okay. Now, can you tell me how many times we can get 50 or 5 into 57? How many? 10 times gives me 50, which means I'm going to have 7 left over, which means I could probably get one more and make it 11, which is now 55, which leaves me with 2 left over. I've said before, and I'll say it again, when you get to these larger improper fractions and you've got to put them into mixed numbers, if you're not 100% sure that what you thought of how many times you can get that denominator into the numerator isn't right, by all means set it up as a division and you'd say, okay, it's 11 and there's 2 left over. Okay? No shame in that. Keep it on a separate sheet if you want to. Don't even turn it in. Doesn't matter. Keith. 10 and 5 sixths divided by 5 ninths. Okay. Need everything in fraction form. 65 over 6. I got to flip because it's division. I only flip which one? I only flip the second one. Becomes 9 over 5. 6 and 9 are both divisible by 3. There's 2 there and 3 there. 65 and 5 by 5. And that's 13. So again, we get this 39 over 2. And if we're not sure, should be 19 and a half. Caleb. 2 and 2/7 divided by 4. Got to get in fraction form. 2 times 7, 14. 14 plus 2, 16 over 7. Now, what is 4 as a fraction? 4 over 1. That's what it is right now. Now, when I flip it, it becomes a 1 over 4. Once that happens, things clear up a little bit. 16 and 4 are both divisible by 4. 4 times 1, 7 times 1 is a 4/7. Joe. 19. Seven and 9/10 times 2/17. Okay. So 11 times 10 is 110. 110 plus 9 is 119 over 10. Do I flip? No, because I'm just multiplying. Okay. And we're there. So 2 and 10, that's obvious. Okay. You know what you did wrong? Okay, yeah. This is just multiply. We don't flip there, so that's okay. If you know that, if you recognize that mistake, that's good. Let's finish it off. 119, 5 times 17 is 85. You're not going to get 2 out of this. Okay? So it's going to be 1. You just need to figure out how much is going to be left. So you subtract, and you get 34 over 85. Can that be simplified? It's easy to say no. Okay, what was this? 5 times 17 gave us the 85, right? So I know it's divisible by two things, 5 and 17, at least. How about 34? Divide it by 2 for me once and tell me what you get. You get 17. 17 times 2 is 34. 17 times 5 is 85. So it's 1 2/5. No, they're both divisible by 17. See, actually, if you were to reduce the 119 and 17, there may be something there. What if we went times 7? 49. Does that give us? So if we would have recognized that right away, we'd say that's a 1, and that's a 7, and you'd get 7 over 5 instead of 119 over 85. I don't expect you to look at a 119 and a 17 and right away say, oh yeah, they have 17 in common. I can divide them both by 17. I don't expect that. But just because you see a 34 and 85 and they're larger numbers doesn't always mean that they don't have anything else that you can simplify them by. Okay? It's all about going that extra mile. All right, here's what we're going to do. We're going to finish the rest of the review tomorrow. I am assigning quiz numbers 1 through 9 on the top. And 13 to 16 on the bottom. Okay, so here it is. Let's see what I mean. What I'm assigning you is essentially more practice on the stuff that we did today. So 1 through 9 on the top. 1 through 4 estimate, just like, was it 1 through 6 on the practice test? Number 5, his beard is 2 5/8 inches long, trimmed 3/4 of it. So you're doing what? Subtracting 2 5/8 minus 3/4. 6 through 9 are all adding or subtracting. Common denominators, yes. At the bottom, we didn't get to the information in 1 through 12 yet, but 13 through 16 we did. Multiplying and dividing, we did some of those just recently. Okay? So that's what you got for tomorrow. We'll check it. Hopefully the results will be better on this tomorrow because we've gone through some of the snags, and then we'll get to the rest of it. And possibly, well, I'd like to test no later than Monday. We'll see how it goes. Okay. Algebra, you can get your stuff out.